And I want you to put next to this to help you out. Solving quadratic equations, really what you're doing is finding x-intercepts by hand, okay, or algebraically. That's what you're mainly doing when most of the time when you're asked to solve for x-intercepts or for solve a quadratic. That's what you're asked to do, okay? So when you're asked to solve a quadratic, you need to determine or find the x-intercepts. And then note that this is very important because I'm going to use them interchangeably, right? X-intercepts, sept or septs, right? One or more is the same thing as what we refer to as root or roots. The zeros, and I'm going to add a fourth one here. We would also say solutions. Okay. So x-intercepts is the same thing as finding the roots. It's the same thing as finding the zeros. And it's also sometimes referred to as the solutions to that quadratic. There are two methods of solving quadratics. The one we're going to learn about today, maybe we'll do both. The first one is using the quadratic formula. If you see QF, you should know immediately what I'm referring to. QF is the quadratic formula. And the second method is graphing. Can I just say this by hand? This is the by hand, and this is using the TI, right? 84. Graphing, you will use your calculator for that to actually graph it on your screen and figure it out that way. The graphing method you've already done. Like I've shown you how to find x-intercepts. There's just a little bit of a twist to it that I'm going to introduce, just a little different method of doing the same thing. Okay, so here's your quadratic formula. Ready for this? Make sure you write it down correctly. So we're going to go x is equal to, we're going to go minus whatever b is. You're like, I'll explain this a little later. Plus or minus. Make sure you have a plus and a minus stacked like that. Square root of, it's a longer root there, b squared minus 4 times a times c. And watch this. I'm going to use a red pen for this just to emphasize the point, because quite often students get this one wrong. So you're going to take all of that, the whole thing, the whole expression from the very beginning to the very end. The whole thing is going to be divided by 2 times a. And these are actually fun once you figure out how to work this out. You'll see that you can have quite a bit of fun with these if you like to crunch numbers. So you're like, where are all these letters coming from, right? It's coming from this right here, okay? This is in general form. Right? So if you have something in general form, meaning no brackets, you can find the values a, b, and c, right? And just plug them into this quadratic formula. This is the quadratic formula right here. And you must add this to your study sheet. Okay. So make sure it sticks out. Okay. That is the quadratic formula. And since we're finding the x-intercepts, under all of these circumstances, watch this, and I just added this later on for my own notes, but I'm going to tell you that in every single case, we always have to make sure and know that y is equal to 0, right? Because we're finding the x-intercepts. If there's a y, we will always make it equal to 0, okay? So just make sure you go back up here and make sure you make a note of this. B squared minus 4AC, which is this part right here. I'm going to highlight that on the, we have a name for it. Okay. B squared minus 4AC, so this highlighted part is called the discriminant. That's the fancy name for it, whatever's inside the root. And if that discriminant, the value, when you crunch these numbers, you have three possible outcomes, guys. It could be positive. So we don't care about the actual value, just the fact that it could be positive. It could be 0, right? Or it could be negative. If the value, if that discriminant is positive, right? Notice a plus or minus there, right? You have two roots, x-intercepts. If b squared minus 4ac is exactly equal to 0, if whatever's in the root is exactly equal to 0, you're going to have exactly one root. One x-intercept. One solution. If it's negative, you have no roots. No x-intercepts. So this is the intro. So we're gonna, every time I ask you to use the quadratic formula to find the x-intercepts, make sure you refer to this on your study sheet. And I would strongly suggest this red line for a lot of students is only under the root here. Somehow this disappears. And so students just divide this section by 2a, and that's wrong. Okay, that's why I use the red line saying that first compute whatever is at the top, then divide everything by 2a. Okay, so let's go and try this out. And I'm going to give you an intro lesson on this one here. So when the question says solve the following using a quadratic formula, focus on solve, right? That should tell you find x-intercepts or the roots. Those are the most common ones used. But I'm going to keep going. Zeros. Those are the three that, if you ever go to the textbook, they sometimes use zeros. It's like, hey, find the x-intercepts. Using the quadratic formula, right? So how are you going to do that? Not by graphing it on your calculator. You're going to use the quadratic formula, right? So that's very specific. You have to use a quadratic formula to get marks here. Okay, note y is going to be equal to 0. Okay, since we are finding x-intercepts. Okay, so y is equal to 0. So you see that there's a y here. So turn that into 0. So we go 0 is equal to 3x squared plus 3x minus 3. That's how you actually want it. You know how we used to make y2 is equal to 0? We were actually sketching a line y0, a horizontal line. So we're actually turning y into 0 before. So that's exactly how you want it to look like. You don't want a y variable to be there. This is now what you're going to say. Based on this, it's in general form. A is equal to 3, positive 3. B is equal to 3. C is equal to negative 3. In a bit, we're going to do some work to make it look like this. Right now, I'm just giving you the most simplest case, right? So we're going to say, okay, to find the x-intercept, I'm going to go minus b plus or minus b squared minus 4ac. So I'm writing out the formula. You don't have to on a test or AC. You can just go right in and plug in. So let's go ahead and do this with numbers. Notice I don't use brackets here because I just quickly wrote it out, but you gotta assume every variable is technically in brackets. So I'm gonna go minus whatever b is, and b is 3, right? Plus or minus b squared minus 4 times a, which is 3, times c, which is negative 3. Make sure the root is over the whole thing. And then we're going to go divide the whole thing divided by 2 times a. If you have, I'm going to use colors here. If you want to follow, you're more than welcome to do so. Right? But B, I'm going to use orange for B. Okay? So we made sure the 3 showed up there. So B shows up 2 times, right at the beginning. I'm going to use green for A, right? And A shows up here, and it also shows up here. I'm going to use pink for C, and C only shows up once. So B shows up twice, A shows up twice, C only shows up once. Okay? So watch how I do this part. You got to watch out. Double negatives turn positive, right? But this is a negative times a positive, so that'd be negative 3. And then you go plus or minus. This is going to give you the potential 2 roots here. Root of, and here I allow you to use your calculator, so grab it. Just have to be careful how you enter it. To be absolutely sure you get this right, if you use brackets, you will 100% of the time get this right. So 3 squared minus 4 times 3, and then brackets again. You got to use negative for the negative 3 inside the bracket. Okay? This is a minus, this is a negative. Okay. So you hit enter and you get 45. So you put root of 45 here. And you got to go over 2 times a. I think we can do this, right? Mental math, 2 times 3 is just 6. And I'll make a note here. Discriminant, I know it's small, but discriminant is positive, right? Therefore, 2 x-intercepts. This will have 2 x-intercepts. And I'll just go first x-intercept. I'm going to go negative 3 plus root of 45 divided by 6. And the second root is going to be x negative 3. Instead of plus, I'm going to now use that minus, right? Over 6. And we're going to get 2 answers there. But you got to be very careful how you enter that into your calculator. So make sure you have that written down and you follow me on the calculator. I think it's overkill, but trust me, there's a lot of things that can go wrong and you're so close to the finish line, right? So you go negative 3 plus root of 45. And please hit enter at this point. Do not divide by 6, right? So you just go enter. Now you go divide it by 6. Hit enter. So that's your first root right there. 0.62 is our first root. And really what you found is 0.620, right? You found that one x-intercept for this curve. And then we do the same thing for the second expression. My trick here is, watch what I do. I just go up to this, the negative 3 plus 45, just hit enter to copy it. And I'll just replace that plus with a minus. And you're like, you're probably faster than me at typing. So for you, it's probably easier to just type the whole thing in again, right? So you get that, and then you divide by 6. Do not forget to divide, right? So the other root is negative 1.62, which is negative 1.620. I will be okay if you just leave it like this. Okay? If you just give me those numbers, as long as you know that you're finding x-intercepts. Okay? And I don't want you to do this because it'll take too much time, but let me just quickly show you. If I were to enter this into my calculator, right? I make y2 equal to 0, and I quickly graph this, zoom standard, and watch. I'm going to find the first x-intercept. It's negative 1618, right? Which matches this one. And then I could find the second one, and it's 0.62. You can't see that, right? It's a bit hard to see, but it's blurry, right? So this matches exactly what your curve would do. So in a sense, you just manually found the x-intercepts of this quadratic function. Okay, so let's step it up a notch. You're like, what? More? It's not really like you did this in grade 10. Okay, so there's not much to do here. But I'm just gonna ask you, when you see something on both sides of the equal sign, bring all terms over to one side. Okay, it doesn't matter which side. If you want to bring everything to the left or everything to the right, right? You should have you should end up having an equals to 0. One of the sides should be equal to 0 when you're all said and done. You're going to have to maybe do a little bit of foiling, distributing before you can bring stuff over. And I slowly step it up a little bit. But after that, it's really just basic algebra. So I'm going to bring everything over to the left side. So meaning the 8x squared is already here. Let's underline that one. And I'm going to match the x squared term. So this 3x squared, when it comes over the equal sign, it changes signs. Okay. Then I have the 5x. I'm going to circle that. Plus 5x. I'm going to circle the x term on the other side. This negative 4x comes over adding. Okay. And the 7, let's do a triangle for 7. Right? That's already on the left side, so just leave it. The sign stays the same, and then you have equals to 0. So essentially what I'm doing is I'm taking 3x squared away from both sides. That's why it comes over negative here. Then I'm adding 4x to both sides. That's why it comes over here as 4x, right? You combine your like terms. 8x squared minus 3x squared is 5x squared. Okay, this combines to that. And then this gives you 9x. And the 7, right, is just on its own. There's nothing to match it with. There's no other constant there. Now you're good to go, right? A is equal to 5. B is equal to 9. C is equal to 7. I'm going to ask you, now that you know these, you can use your quadratic formula, right? I want you to use the quadratic formula and see what you get before we continue, okay? Try it out right away. So I'll do that with you. Negative b plus or minus b squared minus minus 4 times a times c over 2 times 5. Right? And if you clean that up, you get a negative 59. This gives you negative 59 over 10. Right? And then you just say, you can make an arrow to it, right? Discriminant is negative. Therefore, no roots, x-intercepts. Okay. And you could graph this. You could actually graph this, like this part right here. Enter this into your calculator, and you would see that it never crosses the x-axis. I'm just going to tell you, be very careful with negatives. It's coming your way where this negative is from the formula, and if b had been negative, then the double negatives turn into a positive, right? So you got to watch out with the sign. That's why whenever there's a negative, I'll use brackets for sure. Let's do another one. Practice is key here. I'm going to ask you to clean this up. Do some distribution here. Bring everything over to one side. What do you get? Right? What do you get when you try that on your own? Remember, just give it a try. Big deal if you make a mistake. It's not a big deal at all. So I'll just quietly do it up here. 9 and 4 is 36, right? And if you just typed it in one shot, you probably just got a 0, right? This discriminant is equal to 0, therefore 1 root. You don't really have to tell me that. The only time that I really want you to tell me is if it's a negative, like why did you stop, right? Why did you come up with no roots? Because the discriminant is equal to, is negative, right? So in this case, it would just be negative 6 over 6, which is just negative 1. Because there's no point going negative 6 plus 0, negative 6 minus 0. You're still gonna get, negative 1 both times. There's no point for you doing that. Okay, so negative 1, 0 is the root here. Okay. So this is how you use the quadratic formula. I guess, yeah, the focus is on getting it where you have A, B, and C, right? You don't have terms on either side of the equation. You just want everything on one side. If there's a y, make sure it's equal to 0. Turn it into 0 so it disappears, and then you're just left with a bunch of x's, right? So this is solving, meaning finding the x-intercepts using the quadratic formula. Okay? Now we're going to use a different method, which I'm just going to flip back to where we started. I told you that there's a graphing method there, right? Graphing method. There's 2 variations for doing that. You're essentially doing the exact same thing. It's just a different method. So come with me to page 22. Page 22, graphing method. You're doing the same thing here, right? We're finding the x-intercepts. So the same thing, if you use the graphing method, you're still finding the x-intercepts, nothing changes. But you have 2 options here. Okay. Option 1, let y equal to 0 if present. Rewrite the equation in general form. Enter the left-hand side into y1 and the right-hand side into y2. And then use second trace 5 to find any and all x-intercepts. Okay. Then there's the second option. This one is my preference because there's no rewriting. No rewriting necessary. Make sure option 2 has that present. So you're basically skipping the second bullet here from the previous option. You have to rewrite. You're not rewriting here. Let y equal to 0 if present. Left-hand side into y1. Right-hand side into y2. Right, then we go second trace 5 to find any and all x-intercepts. Note, since you're finding x-intercepts, you must state your answer as this, right? It's very important. So here it is. We'll do both methods side by side, okay? So you see that the differences. You will ultimately get the same answer. Okay, so here we go. Option 1, rewrite. If there's any y, we will make that equal to 0 or essentially cancel it out, right? But in this case, there is no y, so we'll skip that step. I'm just going to distribute this already like this. It's my first order of business here. So 32 x squared minus 15x plus 50 is equal to 12x squared plus 250x minus 150. sorry, y minus plus 150, sorry. And then we bring everything over to the left in my case. So I'm just going to underline the x squares. I'm going to circle the x's, right, and put a triangle next to the constant. Okay. So I'm going to go 32x squared. I go over to the other side, there's an x squared there, right? When it comes over the equal sign, it changes sign. Okay. Then I'm going to take the negative 15x. I'm going to go across the equal sign. I see a 250x. It comes over subtracting. Okay, 250x came over here, negative sign. The 50 that I already have on the left side, the sign stays the same, but the 150 on this side comes over subtracting. And then you put equals to 0, right? There's nothing left on the right side. We brought everything over to the left-hand side. That's why you will notice that the other method is faster and less time consuming. Okay, so we combine these. We get 20x squared. We combine these. We get negative 265x. And we combine the constants, and that gives me negative 100 equals to 0. Could we use the quadratic formula right now? We could, but right now I'm focusing on graphing method, okay? So I'm gonna, and you can show it like this, you can show your work like this. I'm gonna make this my y1 and this my y2. And you did this already. I think if you see this, like we've been doing this to find the x-intercepts, I know, but we need to focus on solving quadratics, and they want us to show it this way. So to grab our calculator, let's grab your calculator here. And the zooming is the issue here, because sometimes the numbers are quite brutal. And hopefully this works out. So I'm going to make y1 there, y2 is equal to 0. I'm going to hit graph. Oops, there it is. So we expect this to be pointing up and being very narrow. My y-intercept is in the negative 100s. See that? The y-intercept? This isn't general form. This is my y-intercept right there. So I'm going to go window, y-min. I'm going to go negative 150. Why negative 150? Because it's pointing up, right? So the vertex is going to be a little lower than that. Where do you think the vertex is going? It's going like this, right? So it's probably has this shape like this. Okay, so I'm going to go to my x max and turn that to 20. Let's try that. Oh, there it is. You see that arm? Came up here. It's a very narrow curve. In this case, we don't need the vertex. Right now, we don't need to see the vertex, right? I just need to see the x-intercepts. So I'm going to go second trace 5. Second trace 5, which is intersect. And find them. Find both of them. Second trace 5. You don't know where your cursor is. I at least can't see it. So I'm looking at these numbers here. There it is. It started to show up there for me. I just went arrow left or right and just watch your y value, if it's coming closer to you or further away from you. Okay. And then I just hit enter 3 times. So the first one you should get negative 0.37 if you round it. 0. And the second one, second trace 5, again, I'm going to go arrow up, jump to the red line, and then cut across, travel to the second x-intercept. That's close enough for me. Enter, 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 and it is 13.62, 13.620. And I wish I would have given you enough space to try using your quadratic formula with these numbers, right? Because it's actually quite crazy. Option 2. My preferred method. But there's a bit of a curveball here. So let's rewrite the whole thing. So if you were to see this on a test and I asked you solve this by graphing, if you're like me and you like option 2, all you need to do here is this. Okay, you're like, okay, I'm going to type this into y1. I'm going to type this into y2. No rewriting. So all of this that you did earlier, not needed. Then we're going to go second trace 5, which stands for intersect. And I think I'm going to introduce you to another zoom function on this one. So press y equals, clear. I'm going to clear everything that's in there. So make sure you type this in and follow me, because I guess the downside is finding the window that works. So the first left-hand side goes into y1, right-hand side goes into let's pretend, before we graph, don't hit graph just yet. Let's analyze this. If you just look at the left-hand side, you know that it's pointing up, right? And it's narrow, right? Looking at the other side, it hasn't quite been distributed, but you're going to get a 12x squared, right? Which is also pointing up, right? So both these curves are pointing up. So what we're going to be looking for is, where do they cross each other? That is the point. That's the point we're interested in. So hit graph. And you're like, this isn't looking very good, right? I agree. So use zoom. We're going to try this. Zoom fit. So if you go all the way down here, see zoom fit, which is 0, option 0. Got to go quite a ways down. That often helps you at least see most of the curves. So we're going to try that. Oh, yes, it did the work. Did it work for you? I hope. Zoom fit. So I went zoom all the way down to zoom fit, and I hit enter, and it froze a little bit, right? And there it is. And we're actually interested in the intersections. You could have a linear function meeting a quadratic. All right, guys? It could be. So let's try to replicate this. I'm just going to do a graph like this. And the other curve is kind of like this. Right? So they're both parabolas. We're going to find both of these intersections. We use zoom fit. Okay? Zoom fit to make that work. And then we're going to go second trace 5. So second trace 5. enter, enter, enter. That is Houston, we have a problem. Did I type it in wrong? Because no secret here, guys, we're supposed to get the same answers. And I get 0.8. So I think I did something wrong. Let me just check. If you see it, let me know. Are you getting 0.8 or are you getting the same as I got here? Are we getting this? Moses, you're getting this? It's Monday, I guess. Let me just, sometimes it's right there and I miss it. 2x squared. Oh yes, I see it. Do you see it? And I probably made you all make that mistake. Look at our original. Plus 75, I made you write down negative 75. I don't know if you did the same mistake. My bad. I take full responsibility. Just change that to plus. We're going to have to run another Zoom fit, I'm afraid. I'm going to try to graph it, see what happens. Oh, it still works. Yeah. Go ahead. Okay, let's try this again. Second trace 5. Enter, enter, enter. Yes. Okay. And you're like, what's up with the 5982, right? You see that? What's up with that y value? That's so not an x-intercept. Just wait. Let's do again a second trace 5. Second trace 5. Travel over to the second intersection. Enter, enter, enter. And so this point right here is 13.62, 5,779.43. We don't want that. But that's the, when you use this method, you are finding the intersections, but we're only going to focus on these ones. So you don't have to write down the whole coordinate when you're writing your test or AC. You just write down negative 0.37, 0, and 13.620 as your answers, right? So essentially, we turn these ones to 0. Okay. So it's my preferred method, but I'm quite comfortable with the window and the zoom. Some of you might not be as comfortable doing that, right? So it does have a bit of a trade-off. I will never make you use one over the other, as long as you know how to do it by graphing. And these numbers are a bit on the crazier side, but you're essentially doing the same thing as the quadratic formula. I would circle zoom fit, right? It helped us to narrow this down. And I'm going to stop here, guys. This is it. I'm going to give you the homework, which is on those pages that are following here. So on page 23, make sure, I don't want you to, right? This is going to be 0, right? Y is equal to 0, so it basically disappears. So when you see a y and you're trying to solve it, that's just what happens there. Oh, I do ask you to solve C and B using the quadratic formula. So we just did that. I'm asking you to solve this one by graphing, but then I also want you to use the quadratic formula to verify what you just got. Okay. So I'm going to say page 23, 24, 25. So 23 to 25. Okay, so I'm going to put that down at the top here. I would, if you can't do them all, I understand that, but I would do every other one, because I do have a mix in there where you're going to get into some issues perhaps when you graph it. So just give that a try, okay? And I will post a key before I leave today and try it out. So I'm basically getting you to mix up using the quadratic formula and using graphing methods to verify your answers, because you should be getting the same thing. Okay. That's it for today, guys.